In this session, we're having a look at index law 3, which states that if we're trying to raise a power to a power, we multiply the exponents. Okay, so very formally it is often written in this form. Okay, so index law 3, if we already have a power, say a to the power of m, and we're trying to raise it to another power n, okay, so usually the brackets will give it away. This is the same as a raised to the power of m times n. Okay, so notice it's quite different from index law 1. Okay, like I said, the brackets will give it away. Here we multiply the exponents, and you know in algebra m times n is often written in short as just mn. Okay, so this is the next index law to commit to memory. Okay. Let's have a look at some examples. Suppose we have 4 raised to the power of 5 and we wish to square it. Okay, well, without applying index law 3, let's see what this gives us. Okay, first of all, squared means times by itself, doesn't it? So really this is 4 to the power of 5 times 4 to the power of 5, because we wanted 4 to the power of 5 squared. Okay, so it means 4 to the power of 5 times itself. Now, just looking at this expression now, we're talking about multiplying two powers. Bases are the same. By index law 1, I can say that this is the same as 4 to the power of 5 plus 5, which is the same as 4 to the power of 10. Okay, so basically 4 to the power of 5 all squared has worked out to be 4 to the power of 10. It is no accident that the product of the exponents, in other words 5 times 2, works out to be 10 here. If you look back at the rule itself, a to the m all raised to the n, we end up multiplying the two exponents. 5 times 2 will give you 10. So that means if we've got something like 3 to the power of 4 all squared, because I'm talking about raising an existing power to another power, right, I can say that means it's 3 to the power of 4 times 2, multiplying the two exponents, which is 3 to the power of 8. Alright, let's have a look at some slightly harder examples. So, suppose I've got, say, 8 to the power of 7 all squared, and then times 8 squared all raised to the power of 4. Okay, so by index law 3, this one will become 8 to the power of 7 times 2, which is 14. And then here I'm talking about raising the 8 squared to the power of 4. So by index law 3 again, this becomes 8 to the power of 2 times 4, which is 8. At this stage, notice that the brackets have disappeared. Okay, so now we're just talking about multiplying two powers. Just multiplying two powers, we talk about index law 1. So this is now going to be index law 1. The bases are the same. I can end up just adding the exponent. So this will become 8 to the power of 14 plus 8. 8 to the power of 22. Okay, let's have a look at another example. This time I've got 10 to the power of 4 all squared divided by 10 cubed. Okay, so this part here is index law 3 because we're talking about raising a power to a power. So this will be 10 to the power of multiply the exponents. 4 times 2 will give me 8. Divided by 10 cubed, which I haven't done anything with yet. Okay, I can think of this as 10 to the power of 8 divided by 10 cubed, written in this form. So now I'm talking about dividing two powers, which is index law 2. So dividing two powers, check the bases are the same. Yes, they're both 10. So we end up subtracting, don't we? So this will be 10 to the power of 8 minus 3, or 10 to the power of 5.